So we are going to review sections 2.4 and 2.5. And you're going to have a review handout to work on in just a few minutes. You'll have the class period, and then anything you don't get done would be homework. So if I gave you an equation, first thing we did in section 2.4 was the absolute values. So if I said something like the absolute value of 2x plus 1 minus 3 equals 18. How would you solve this? Add your 3. First, no matter what, if it has an absolute value, you have to isolate that. And then what do? Two equations. You set it equal to a positive 21 and a negative 21. So then we just solve each of those. So if we subtract our 1, divide by 2, we get positive 10 and negative 8. Is that okay with everyone? So if I gave you the equations to solve, you know what to do there. If you had an absolute value equal to a negative, like if right at this step it was 2x plus 1 equals negative 21, what would your answer be? No solution. Absolute value can't be negative, so you could just stop there. Okay, then we did inequalities. So if I said okay, first step was again always isolate the absolute value. So you'd have to multiply by 2. And then we had to ask ourselves, is this an and or an or statement? Or. Great or is an or. So when we have an or, we are expecting 2 different answers. How we set this up, the first one we just drop the absolute value. With the second one, we drop the absolute value, flip the sign, and made it a negative. Okay, so then if I solve these, I add over my 3, divide by 5, if it helps you, you can draw a number line. That's not necessarily part of your answer, but it can help. Or these things should be going separate directions. So greater than or equal to 13/5 looks like this. Less than or equal to negative 7/5 looks like this. So my answer is negative infinity to negative 7/5. Because of the equal to, it gets a bracket. Union, the next piece started at 13/5 and went to positive infinity. And again, anytime your answer is an or, that's what it's going to look like. 2 separate pieces. The third absolute value type problem we had was something like this. So the absolute value is already by itself. Less than means what? And. When we graph an and, it's just going to be one interval, okay? So it'll be between two numbers. What we did is we usually just did a compound inequality. We put this in between the negative and the positive. So then to solve for a, you subtracted your 4 from everything. And then what did we do? Divide by -2. When you divide by a negative, what happens to your inequalities? So I get 7/2 is greater than a is greater than 1/2. Okay, not used to how we have our, or not how we're used to seeing it, but this tells me that the a is smaller than 7/2 and it's bigger than the 1/2. It's just in between those. And that's the case every time it's an and, you're just going to get one interval for your answer. That was section 2.4. 2.5 was when we got into the piecewise functions and the greatest integer. So I don't think I'm going to work out examples of those. Those are a little more recent. What I want to do now is give you the chance to practice on these. So if you have like the absolute value of 2x is greater than -3. So anytime we have a negative over here, we need to just stop and think for a second. We know if it was an equal to, it would be no solution. Absolute value is positive. How often is a positive number bigger than a negative number? Always. So that answer would just be negative infinity to positive infinity. If I had the absolute value of 2x is less than or equal to -3. So less than means smaller. When is a positive number smaller than a negative? Never. So that's a no